In Chapter 7, the text provides an example of a cost minimization problem. Let's take a look at working through that problem here. In the simple cost minimization problem, we have M&D Chemicals, which produces two products. It produces a product A and product B. Some of the information that is provided is a goal on the part of management to produce at least 350 gallons of products A and B, any combination as far as management is concerned. But separately, they have a major customer who has placed an order. They have an order to fill. The customer wants 125 gallons of product A. So there's a constraint for product A in addition to the one for A and B. Now, to manufacture these products, product A requires 2 hours of processing time per gallon, while product B requires 1 hour of processing time per gallon. In the upcoming month, which is their production cycle, they have 600 hours of processing time available. This is a cost minimization problem. The production costs for product A are $2 per gallon, and for product B, they are $3 per gallon. What M&D Chemicals wants to know is what is the best mix of products A and B to manufacture over the next month to minimize cost, and what would that minimal cost be? Let's set up the model using the information that we're provided. First question that we ask ourselves, what are we making? We're making product A and product B. Then we're going to look for a solution. How many of each are we going to make? That's the next question. How many? Solver is going to answer that for us. We'll put the solution value there. And I'll make that yellow so that we can see that's going to be the solution row. Now this is a cost minimization problem, so we have to indicate what the elements are that go into satisfying our objective function. And our objective function, our objective is to minimize cost. We want the lowest cost number we can get. Now, cost for production for a gallon of product A is $2. For a gallon of product B is $3. We're going to have Excel and calculate our lowest cost based on the production volume, and we'll put that figure right there. So as Excel puts various production levels of these two products in there and assigns a cost to them, it's going to find the lowest cost. But of course, we don't have unlimited resources, so we have constraints. We're going to put this together with some constraints in mind. Now with cost minimization problems, you need some kind of constraint that instructs you to make so many. The easiest way to minimize cost is to not make anything. But you have demands, you have inventory that you may need to keep, you have orders that you need to fill. You can't just produce nothing, that's going out of business. So we're going to put constraints in many cases that deal with the quantity of items produced rather than what goes into the items, and to some extent what may go into the items as well. So let's take a look at a couple of quantity constraints that are provided. First of all, management provides us with a quantity constraint. They've established a product A and B production minimum. They want to see at least 350 gallons of any combination of product A and B produced. Then we have a customer order. So we have a product A minimum. Customer has ordered 125 gallons. We have to be sure we fill that order. Then we are constrained with regard to production time. We only have so much production time in the mix. We have a constraint that we can't exceed, the production time constraint. So each time we make a product A or a product B, we want to count it toward that constraint. That's how we deal with a quantity constraint. We count items toward a max quantity produced. Each time we produce a product A, we want to count it. Nothing for product B. Product B doesn't apply to the product A constraint. Production time, how much time does each product contain? So this is a content constraint. It takes 2 hours of production time to make product A and 1 hour of production time to make product B. Let's go ahead and center these so that you can see them a little bit better. Those are the values we need to check against our constraints. So let's take a look at what sign is going to go with these. Now these are minimum constraints. We have to make this, so it have to be greater than or equal to, and this constraint was 350. That's what management wanted. This is a greater than or equal to. We have an order for 125 of these, but this is less than or equal to because we only have 600 hours of production time available during this production cycle. So I'll change the colors here so that we can see the values we're going to put in. All right. Now we set our model up. Now we have everything in place. We'll put our sum products in, sum product. And again, always the solution set, absolute, comma, the row to our left, parenthesis. Put on here, sum product, the solution set, absolute, comma, the row to our left. Enter. And that's the same all the way down, so we can just copy that down. You can see we'll check, press F2. There we have it. All right, I'll go ahead now and place my cursor, my objective, value, select data, solver. Here's my objective. This is a cost minimization problem by changing the variable cells B2 and C2, the yellow cells here. I want to add some constraints. I like to move this over so that I can see. I'll go ahead and do my less than or equal to constraint first, just to show you that you can do them out of order. It doesn't matter. Here's the cell reference for that constraint. That's where the value is going to go. Here is the constraint value itself. Now I have more constraints that I want to add, so I'm going to select Add. I'll go ahead and select the cell reference for my two greater than or equal to constraints. Select the greater than or equal to symbols, and then I will select my constraints and say OK. Have those set up. I'll make sure that box is checked. I'll go down and change this to simplex LP. Move this out of the way so you can see. I'll select solve. Now I want to go ahead and generate an answer report. The text talks about those. Select OK. It creates the answer report down here, answer report number 3. This shows me that I'm going to make 250 of product A and 100 of product B. My minimal cost is going to be $800 for that production cycle. I'm going to meet the A and B product minimums exactly. Not going to make any more than I have to. I'm going to exceed the order by our customer of 125. I'm going to make an additional 125 for stock. And I will use all of my production time. I have no slack here. So a little bit of slack here. Let's take a look at our answer report. You can see that here's the cost. I'm going to minimize that cost figure, $800. By producing 250 of product A, 100 of product B, We're going to meet the demand by management of at least 350 gallons of either product A and B. It's a binding constraint. There's no slack. We're going to exceed our order of at least 125 by making 250. This has a slack of 125, so it's characteristic of a non-binding constraint. Finally, we're going to use all of our processing time, no slack, again, a binding constraint. That's how you solve a cost minimization or any type of minimization linear programming problem in Excel.